Decoding the future of AI. Welcome to AI Perspective. Just a few weeks ago, if you wanted to tap into the pinnacle of AI vision and reasoning, you'd be looking at a server farm, a colossal investment, and a team of specialists. Today, a 7 billion parameter model, a true rebel in the world of artificial intelligence, is achieving that same level of brilliance on a gaming rig. And in the process, it's leaving models 10 times its size in the dust. Xiaomi has just unveiled MiMo-VL7B, and it's not just another model, it's a paradigm shift. It sees every detail, reads every word, thinks through every problem, and it's doing it all without the gargantuan size we've come to expect from top-tier AI. This is the incredible story of how Xiaomi cracked the code and is poised to democratize the future of artificial intelligence. So what exactly is a vision language model? Imagine an AI that can look at a photograph, watch a video, read the text within it, and then have a coherent, in-depth conversation with you about everything it has just processed. Most of the systems that excel at this are massive, with 30, 70, or even more billion parameters. Xiaomi has managed to distill that same incredible power into a model with just 7 billion parameters. This is a game changer. It means significantly less hardware is needed to run and fine-tune it. That's the first major headline, smaller yet mightier. So how did they do it? Let's peek under the hood of MiMo VL7B. At its core, it's composed of three critical components working in perfect harmony. First, we have the vision transformer. This is the part of the AI that sees. And it sees with remarkable clarity, processing images at the same high resolution that you and I would see on a top-of-the-line monitor. This means no crucial details are lost or blurred before the model even begins to think. Next, there's a small but vital piece of code called the projector. Its sole purpose is to act as a universal translator, taking the visual information from the vision transformer and converting it into a language that the text-based part of the model can understand. And finally, we have the MiMo-7B language backbone. This is the brain of the operation, the part that constructs sentences, explains its reasoning step by step, and can produce incredibly detailed and lengthy explanations if prompted. This language model was specifically designed for deep reasoning, not just quick, superficial answers. Now, a model this powerful doesn't just appear overnight. Xiaomi's journey to creating MiMo VL7B was a marathon, not a sprint. It involved a meticulously planned four-phase training process that consumed an almost unimaginable 2.4 trillion, that's trillion with a T, pieces of data, or tokens. A token can be a word, a part of a word, a chunk of pixels, or a snippet of code. Phase 1 was essentially the model's kindergarten. The vision and language components were kept stable, while the new kid on the block, the projector, was trained on 300 billion image caption pairs. It learned to associate a visual representation of an orange root vegetable with a green top with the word carrot. Only after this crucial warm-up did they move to Phase 2. Here, they unfroze the vision component and introduced a massive dataset of 167 billion lines of mixed web pages, textbooks, and PDF snippets. This taught both sides of the model how images and sentences coexist and relate to one another. Phase 3 is where things get truly wild. The model was fed a staggering 1.4 trillion tokens covering almost anything you can imagine photographing or writing about. We're talking about shaky real-world photos of street signs, complex diagrams from physics textbooks, screenshots of mobile apps, and even short video clips with time-stamped captions. During this phase, they kept the model's memory buffer, or sequence length, at a generous 8,000 tokens. But they didn't stop there. In Phase 4, they cranked that memory buffer up to an incredible 32,000 tokens. To put that into perspective, the model could now read an entire chapter of a college textbook, analyze a high-resolution photograph, and still have enough memory left to generate pages upon pages of detailed explanation. It was during this final phase that they also flooded the training data with synthetic reasoning problems, complete with step-by-step chain-of-thought solutions. This taught the model not just to guess the right answer, but to reason its way there explicitly. And the quality of this data was paramount. Xiaomi didn't just blindly scrape the web. They used perceptual hashes to ensure their training data didn't overlap with their test sets, preventing any form of cheating. They employed specialist captioners to improve the grammar and context of image descriptions. They filtered for knowledge density, keeping the rich, informative content and discarding the fluff. For optical character recognition, they included images with blurry, handwritten, or partially obscured text to build resilience. They even went as far as to create a synthetic dataset of Chinese language app screenshots to ensure the model wouldn't be stumped by different languages and user interfaces. After these 4 intensive phases, they had the supervised fine-tuned model, MiMo VL7B SFT. But Xiaomi wasn't finished. They pushed the model through another incredibly challenging process called Mixed On-Policy Reinforcement Learning, or MORL. Now that might sound like a bunch of technical jargon, but the concept is brilliantly intuitive. They let the model answer new questions, and then they scored those answers in 2 distinct ways. For tasks with a verifiable right or wrong answer, like identifying an object in an image or solving a math problem, the system could automatically check the model's work and provide a clear thumbs up or thumbs down. For more open-ended questions, like providing helpful and unbiased instructions, Xiaomi trained separate reward models on thousands of human-ranked answers. This taught the AI to understand what kind of responses people find preferable. The on-policy part of this is crucial. It means that every time the model generated an answer, the training code instantly measured the reward and updated the model based on that fresh experience. This is far more efficient than the older method of mixing new experiences into a large, pre-existing buffer. The results of this reinforcement learning were undeniable. On the massive mixed subject benchmark MMU, the model's score jumped from 64.6% to 66.7%. Its ability to count objects accurately climbed from 87% to over 90%. And on a benchmark designed to trick vision language models, it scored a solid 80%. But where MiMo VL7B truly sends shockwaves through the AI community is in its performance on multimodal reasoning. On Olympiad Bench, a collection of exam-style science problems, it scored an impressive 59.4. On Mathverse, a benchmark heavy on diagrams, it posted a score of 71.5. These scores match or even beat models that are 10 times larger, like Quen's 72B. Xiaomi's 7 billion parameter model is now nipping at the heels of closed-source giants like GPT-4o and Gemini Pro. And this isn't just about academic benchmarks, it's about real-world utility. For anyone building AI agents that need to navigate and interact with websites, MiMo VL7B's skills are a revelation. On Visual Web Bench, which tasks models with finding information on full web pages, it achieves around 80% accuracy, putting it neck and neck with GPT-4o. It can pinpoint the location of buttons on a screen with over 90% accuracy. In one stunning demo, Xiaomi showcased the model acting as a personal shopper. They opened an online store page and asked the model, in plain language, to select a specific car model with a custom paint job and interior, and then add it to the wish list. MiMo VL7B parsed the screenshot, clicked the correct color swatch, scrolled to select the right trim, pressed the wishlist icon, and then produced a perfect action trace that an automation controller could execute flawlessly. This is the power of high-quality grounding and reasoning, all packed into a lean 7 billion parameter brain. So what does the arrival of MiMo VL7B truly signify? It proves 3 fundamental things. First, curation is king. By strategically introducing reasoning-heavy data later in the pre-training process, Xiaomi was able to continue squeezing out performance gains where other models would have plateaued. Second, on-policy reinforcement learning is not only stable for smaller models, but continues to deliver improvements deep into the training process. And third, it is possible to advance perception, grounding, and reasoning simultaneously with a careful balancing of reward signals. Put simply, the gap between hobbyist-sized open-source models and the top-tier proprietary stacks is closing at a pace that almost no one could have predicted just a year ago. So what do you think? Will small, sharp, and efficient models like MiMo VL7B make massive, resource-hungry AI stacks a thing of the past? Are we on the cusp of a new era of AI, where groundbreaking power is accessible to everyone? Drop your thoughts and theories in the comments below. And if you found this deep dive into the future of AI as fascinating as I did, make sure to hit that subscribe button and give this video a like. Thanks for watching, and I'll catch you in the next one.